Yes, there are a lot of people that partake of cannabis products, and so many people have become acquainted with some of its effects, such as red eyes, dry mouth, and of course the munchies. But very few people actually know why these things happen. Plus, there seems to be a debate on whether cannabis products are addictive. So today, using real human cadavers, we're going to walk through the anatomy and physiology behind some of the most common side effects of cannabis consumption. We'll see what structures and systems are actually being affected, and of course, we'll discuss whether or not cannabis is addictive. This is going to be full of all sorts of anatomical and physiological awesomeness. So, let's do this. The first thing we want to understand is that tetrahydrocannabinol, THC, and cannabidiol, CBD, are both examples of what are called cannabinoids. These cannabinoids are found inside the cannabis plant, but there are actually over 100 known cannabinoids. THC and CBD are just the two you hear the most about. THC is the primary psychoactive cannabinoid, while CBD is considered mostly non-psychoactive. These cannabinoids bind to receptors on the outside of cells called cannabinoid receptors. And those receptors are part of a much larger signaling network known as the endocannabinoid system. And there's still a lot we don't fully understand about this system. But one important thing to keep in mind for this video is that there are two main types of cannabinoid receptors. CBD1 receptors, which are found mostly in the brain and nervous system, and CBD2 receptors, which are found in immune and peripheral tissues, although both types can be found throughout the body. What this means is that when you consume THC, it's not just going to your brain, it's interacting with tissues all over your body. And one of the first places we'll talk about is the heart. So here we have a heart sitting in its pericardial sac. We know the heart is this incredible organ that is constantly pumping blood and keeping you alive. But it also can be affected by THC. When THC is first consumed, it commonly causes an increase in heart rate. But at the same time, THC causes blood vessels to relax and dilate. So even though heart rate may increase initially, the dilation of blood vessels can actually cause overall blood pressure to drop. And when blood pressure drops, that means less pressure is pushing through smaller vessels throughout the body. And that brings us to the small blood vessels of the eyes. The eyes contain a very high density of cannabinoid receptors, and the blood vessels supplying the eyes also contain these receptors. When THC binds to them and blood pressure drops, the small blood vessels, especially the capillaries within the eyes, begin to dilate. As those vessels dilate, the vessels will hold more blood. And this is what gives the eyes their characteristic red appearance. And this is also why this doesn't happen immediately. Someone doesn't just consume the THC and instantly has bright red eyes. It takes time for these vascular changes to occur. Another very common side effect of cannabis use is dry mouth. And to understand why that happens, we need to look at what normally keeps your mouth moist in the first place, and those are the salivary glands. Here you can see an example of the largest salivary gland called the parotid gland, which actually translates to the gland beside the ear. Maybe you felt that aching sensation when you eat something sour. Well, you can thank the parotid gland for that. And here we have another salivary gland called the submandibular gland, which is below the mandible. There are also sublingual glands beneath the tongue. But obviously these glands produce saliva, which lubricates the mouth and also contains enzymes that help break down carbohydrates. The key point here is that salivary glands contain a high density of cannabinoid receptors. When THC binds to those receptors, it downregulates saliva production. And so when saliva production drops and it's no longer moving into the mouth dries out. And now would be a good time to address some misconceptions about dry mouth and red eyes. Because for a long time, it was assumed that red eyes and dry mouth were simply caused by the smoke itself, this hot, dry air irritating the eyes and mouth. And that explanation seemed to make a lot of sense to many different people. But once cannabis started being consumed in non-smoked forms, like edibles, people were still experiencing red eyes and dry mouth, which told us something else was going on. And what's really responsible is not the smoke. Because as we just learned, it's the cannabinoids interacting directly with the receptors located in various tissues throughout the body. This is also a good place to point out that the way cannabis is consumed changes how quickly and how long these effects will last. When cannabis is smoked or vaped, THC enters the bloodstream through the lungs and reaches the brain and other tissues within minutes. When it's ingested, it has to pass through the digestive tract and the liver first, which is why edibles take longer to kick in, but often last much longer and can feel more intense at times. But now we need to talk about what is probably the most famous side effect of all, the munchies. And to help us understand what's really going on with the munchies, we're going to take a look at this sagittal head dissection. And you can obviously see some very cool structures here, like the nasal septum, the corpus callosum, the brainstem, and my personal favorite, the cerebellum. But what we want to focus on is this small but incredibly important region here called the hypothalamus. The hypothalamus acts a bit like a thermostat for the body, or in other words, it helps maintain homeostasis. It helps regulate things like temperature, hormones, and hunger. And inside the hypothalamus are specialized neurons called pro-opiomelanocortin neurons, which we'll just call POMC neurons. These neurons are involved in satiety, or feeling full after a meal. So when they're activated, you feel full and stop eating. But here's where things get interesting. THC binds to cannabinoid receptors on these neurons, but it also affects signaling inside the neuron, including interactions at the mitochondria. Mitochondria are the energy-producing structures inside the cells, and when THC alters signaling here, it changes how these neurons behave. Instead of producing a normal "I'm full" signal, there's a release of endorphins that essentially overrides that sensation. The result is increased appetite. Now, a lot of this is still being actively researched, and the exact mechanisms are still being worked out, but the big picture is that THC disrupts normal satiety signaling in the hypothalamus, resulting in the increased appetite. Other hormones are also involved, including leptin and ghrelin, which regulate hunger and fullness. But when people find themselves demolishing an entire bag of chips, this interaction at the hypothalamus is a big part of why that's happening. So up to this point, we have focused on the acute effects of THC. But with repeated or heavy use, it's important to talk about what can happen over time, because this is where terms like tolerance, dependence, and addiction often get mixed together. THC repeatedly activates cannabinoid receptors, especially CBD1 receptors involved in reward, motivation, mood, and stress regulation. When those receptors are stimulated again and again, the brain adapts. One of the most common adaptations is tolerance, meaning the receptors become less responsive and higher amounts of THC are needed to produce the same effects. In some individuals, tolerance can progress into dependence. Dependence simply means the brain is adjusted to the regular presence of THC, and when use suddenly stops, the system needs time to recalibrate. During that period, people may experience withdrawal symptoms such as irritability, anxiety, changes in sleep, or reduced appetite. These symptoms reflect neurochemical adjustment, and they typically resolve with time. Now, dependence is not the same thing as addiction. Addiction refers to a behavioral pattern in which use continues despite negative consequences with impaired control, cravings, and disruption in daily life. Clinically, this pattern falls under a diagnosis called cannabis use disorder, which exists on a spectrum from mild all the way up to severe. Importantly, someone can show signs of dependence without meeting the criteria for addiction. And looking at lifetime risk, population data suggests that roughly 1 in 10 adults who use cannabis will develop dependence or meet criteria for cannabis use disorder at some point. But when cannabis use begins during adolescence, while the brain is still developing, that risk increases to about 1 in 6. In terms of current prevalence, an estimated 14 million people aged 12 and older in the United States met criteria for cannabis use disorder in 2020. And by 2023, that number had risen to about 19 million, representing a significant but still minority portion of overall cannabis users. For additional context, the overall risk of developing addiction to cannabis is lower than for substances like nicotine, alcohol, or opioids, but it is not zero. Alcohol and opioids do carry a much higher risk of severe physical dependence, organ damage, and overdose, which is why they contribute to a greater burden of disease and mortality. Cannabis falls lower on that spectrum, but that does not mean it is risk-free, especially with frequent use, high-potency products, or early exposure. So no, not everyone who uses cannabis becomes dependent or addicted. Many people use cannabis without ever developing significant problems. But THC is also not biologically neutral. It interacts with real neural circuits involved in reward, motivation, and stress regulation. And like any system in the body, those circuits adapt to repeated stimulation. The takeaway here is balance. The endocannabinoid system evolved to function within a certain physiological range. repeatedly pushing that system in one direction, especially with frequent or high-dose THC exposure, can lead to adaptations that are not always desirable. And understanding where those lines are can help people make informed decisions about its use. One of my biggest goals with teaching in this lab and making online content is to spark that love of learning in people, helping them unlock what they're truly capable of. And that's exactly what Brilliant, the sponsor of today's video, has helped do for me. Brilliant turns anyone into a confident problem solver. Whether you're tackling math concepts that used to trip you up or diving into computer science ideas, Brilliant helps those concepts click in a whole new way. I've personally been using Brilliant to sharpen my skills beyond biology because it's been a while since I've taken a math class. So lately I've been getting into their lessons on exponential functions, and I love how Brilliant helps you excel through visual, interactive problem solving and personalized practice that builds genuine understanding. Their courses are also crafted by an award-winning team from places like MIT and Caltech, starting you at the right level based on your background with practice sets and end-of-level reviews personalized just for you. Now, a lot of you watching might be eyeing the medical field, and trust me, Brilliant's got you covered with lessons that build the foundation for the math and data analysis that you'll need. Plus, since many users learn on their phones, it's seamless to jump on at any time. And so if you want to try learning for free on Brilliant for a full 30 days, go to brilliant.org/IHA, scan the QR code on screen, or click the link in the description. Brilliant is also giving our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thanks again to Brilliant for sponsoring today's video, and thank you to all of you for watching and supporting our channel. And of course, we'll see you in the next one.